Hey, hi, it's me again. Yeah, Calvin, your speaker today. So, yeah, before we start, right? So let's have a round of maybe sound check and so on to check. So I guess, still snowing. Right. Okay, I guess. Hold on. Let me hear whether I can hear myself in the live or myself first. Okay, good. Yeah, I can hear myself in here. Okay. Yeah, good afternoon, everyone. So yeah, thanks for joining us again for today. So I hope you guys enjoyed the session for the past 2 days. So which is talked about uh, the superheater and also choke valve. So for today, we will talk about safety valve. So during the presentations, right, maybe you guys will see the similarity between the pressure regulator that we have taught previously, especially on the back pressure or relay functions. But indeed, there are a vast actually there are vast difference between these two products. So first of all, the design are different, and secondly, the application are actually different as well. So for pressure regulator, it's actually considered as a self-actuated control valve. So which mean during the normal operation on site, so it will keep operating means that the seat it will keep open and close to regulate the pressure. But for safety valve, is serve another function. So it serves as a safety barriers to prevent the overpressure. So maybe without further ado, let's us proceed to the slides. Then if you can have any question, just feel free to drop your question. Then I will try to attend to you shortly. So yeah, I try my best because today I will be the one who do the presentation. So yeah, it might take some time to answer to your questions. Yeah, so let me share the slides with you guys. Okay. Okay, put it on full screen. Okay, let me check whether it's okay on your screen. Okay, seems nice. Okay, yeah, much better now. Right, then okay, let me start the session today. Yeah, Chong, this is my room, but currently it's not sorry. we are living in Malaysia. Right. So, okay, before I go into the so-called safety valve first, then perhaps I can have a brief intro on why this equipment is required. This equipment is required on site. So let us start with the slide that provided by our counterpart, Mr. Andrea Consoni, the engineering manager from one of our principal, which is AST. So, okay, let's talk about the safety equipments. So for safety valves, actually their primary objective is as the overpressure protections. So in daily operation equipment in plants, so we can't ideally the pressure should be constant and it won't have any overshoot. But in actual life, there are some certain factors which cause the pressure to goes up until a very dangerous level. So it might due to the operator error, maybe the blockage in discharge, so the flow it accumulate and the pressure builds up. So or even worse things like the equipment failures, like the check valve, or some of the other utility equipment failures, and even much more catastrophic disaster like the fire explosion, which causing the fire, because when the process gets being caught on fire, so the first thing is the pressure, the temperature will be arise, and secondly, so temperature arise, your equipment fail, and then the pressure. So that means the equipment on site they can't control the pressure properly. So in order to counter on this disaster, so usually plant they will have a few so-called means safety equipments. So those are either by the inherently safe design of all of the equipment and also the elements on the on the process, sorry, in the process plant, or maybe the passive or the active control. But the thing is, since that for the inherently safe design it can eliminate most of the hazard, because means that your design is able to respond to any possible failure or any possible catastrophic failure. But still, good thing come with a good price. So in order to solve this so-called, to prevent this overpressure thinking from happens, and to do it in a very in a way that we also consider in the commercial aspect. So actually the pressure relief valve, not relief valve, pressure relief devices are widely used in plant even nowadays. Okay, so right. So first of all, the process system designer, definitely they should evaluate, and they should take in the consideration during the design of the plants. So which I guess some of you might have the access to the plant layout. So you can show that how they put in all the equipments, how they consider the design, the specification requirement on site, and what are the safeties features that have added into the system. So you see, one of the most difficult things to control is the cause of the overpressure. So because we have different equipment and different element on site, and sometimes we can't really control, put everything under our control. But the best we can do is we can try to prevent it, and we can have the certain equipments in order to be as a insurance, or maybe the assurance, just in case things happen, everything can be the risk can be contained. So for all the pressure for all the pressure safety devices, so definitely they will need to follow the guides of the few standards. So two of these are the API 521 and also ISO 23251. So these two standards specify the requirements and provide the guidelines in examining the causes of the overpressure. Okay, so these are the codes of standards that been followed by most of the pressure safety devices manufacturers. So some of those that you can see that which is applicable to our topic today, which is the pressure safety valve, is those are for the those are the ASME standard. So ASME standard, and also for sizing selection, so those will be compliance to API 520. And for our main topic today is on the safety valve. So that design will definitely need to follow on the API 526, which is govern the standard for the flange steel pressure relief valve. And let's not forget about the ISO standard, which is the ISO 4216. So this standard can be quite tedious, but if you refer back to the catalog of the safety valve, so they will show that the design or maybe the calculation and selection, they are based on what kind of standards. Right. So the next one is, okay, we will move into the type of the pressure relief device. Okay, after I talk a lot of dry things about standards and so on, maybe I'll just go around on the on our comments, see whether we have have any comment from the floor. Okay, so from Louis Kong, do we need to employ pilot to man the safety man the safety valve? Well, first of all, definitely it's not pilot. So pilot, from what I know, is the one that driving the airplanes, perhaps. So it's not really to employ a pilot or someone to man the safety valve. Safety valve is actually some equipment that we install in the site. So if let's say nothing happens, so actually it doesn't need to do anything. It just sits there. It just sit there quietly. Okay, thank God nothing happened. But on and off, we will have okay. So on and off, right, we will have the scheduled maintenance. So which means the plant operator, they will have a plan of the maintenance to change some of the parts, especially those elastomer parts. That one is to prevent the elastomer from deteriorating, and also to make sure that the valve is still still in a functionable status, just in case things happens. Okay, so yeah, same. So today we are talking about pressure relief. So as I mentioned just now, so it's actually different compared to the pressure regulator relief functions. And yeah, so I guess Andrea is a quite common name in Italy. So we have a famous football player, Andrea Pirlo, and actually in UK we also have Andriy Shevchenko, right? So it seems like it's a very common name, not like Calvin. You don't you don't see people named Calvin as always. Right. Okay, so let's continue to our session today. So for pressure relief device, right? So in a big picture, there are two types. One is is it? Yeah. So one is which we call as the reclosing pressure relief device, and the second is the non-reclosing pressure relief device. So in simple term is that so as you can read from the slide, so it's actually quite long. So in simple term is that for the reclosing, so is that once that the safety device is being activated or maybe is being triggered, so after a certain of time or during when the pressure is slowly relieved and also reducing, and then the valve can actually back to its previous conditions, and still can be you can put it in a way that it still can be continued to operate as the safety features. But for those that non-reclosing, right? So once that is being triggered, a manual resetting is required. And also for some of the type of the pressure relief devices, you actually need to replace them. So let's move into the next one. So here is the type that usually how a plant designer they have in the consideration when they're choosing whether it's to utilize the non-reclosing or the reclosing type. So when to use a non-reclosing safety device? So some of the factors including like the capitals. So some of the factors, interrupted. Some of the factors like the capitals and maintenance servicing. So a very rapid pressure rise situation like runaway reaction. So it's like you need it to react very fast. Means that once thing happen within a split second, then it can be triggered and release the overpressure. So as you can see, so in here they're actually listing that losing the contact is not an issue. Then for non-toxic and non-hazardous services. So and also for some of the applications like some of the processed fluid like the high viscosity liquid, and also the needs for reduced fugitive emission. So on the second is that right when to use a reclosing safety valve. So is that so the very first point, as I say, right, because not non-reclosing, for the reclosing safety device. So after a matter of time when the pressure is back to normal, so the valve will back to its original position. So as stated in here, so the first one is losing entire contact is unacceptable, and it's able to return to the normal operation quickly, and then. The third factor is it can be withstand the process pressure changes, including vacuum applications. So the set pressure is insensitive to the when the set pressure is insensitive to the temperature and not affected by the fatigue. So the last one is when the plant user they require a safety device that is easy to test, and also the in-service test is required. Okay, right. So these are some of the examples of the non-reclosing pressure relief valve. So as I mentioned just now, pressure relief devices. Oh, sorry, I keep saying the wrong thing today. Okay. So one of it is the rupture disc. So once that it's been triggered, means that it's burst. So you will have to replace it. So I guess the major type is these two. So the major type of the non-reclosing pressure relief device is either rupture disc or the pin actuated devices, which sometimes you might see as the they call as the buckling pin safety valve. One is buckled, then you will need to change the pin. And okay, just to just as an information sharing with you guys. So our principal ASD, they are not actually not manufacturing this non-reclosing pressure, but instead they are more expertise in manufacturing the reclosing pressure relief device. So this non-reclosing pressure relief device actually included which is the safety valve that we keep. That most probably you guys always heard of. And for safety valve, right? So later on we will talk about there are actually two types of it. One is the conventional, and the second one is we call as the balance type. And there's another one for the special application, which is the pilot operated safety valve. Okay, then before we go into the safety valve, then maybe I can share with some of the terminology or the terms that being used when you guys dealing about the safety valve. So first of all, it's definitely the inlet diameter. So this one usually for the inlet diameter and outlet diameter. So this we have to inherit. Sorry, not really inherit. Is that we have to comply back to specification on site. So first thing first, we need to make sure that the size that we propose is the same with the pipeline. The size of the pipeline for the installation. So as you can see from the slide, so the A is like inlet diameter, so which is where the flow is coming into the safety. Is flowing into the safety valve. And due to the difference, due to the ASME standards, right? So the required for the thickness, required for the valve thickness. So you can see that, for instance, for a 4-inch valve, right? Different rating, they're actually having different inlet diameter. So the second one is B, is on the nozzle diameter. So this nozzle diameter is is a one that will be decided on the flow that flow into a safety valve, and it will affect when we are tuning the step pressure of the safety valve. And the third one is which is showing in C which is showing C in the slides, which is the effective seat diameter. So this is the diameter we use to calculate the truss area. This is critical in terms of the safety valve design, because it also determine what type of spring that we need to use, what are the nozzles that required for certain applications. Okay, then I think for step pressure, you guys already know what is that, which is mean that we can put it as the trigger point, or maybe in safety valve is mean that for example, we put the step pressure on maybe 15 bars to maybe 50 bars. So once that the line pressure, means that the pressure in the pipeline exceeded 50 bars. So the safety valve will trigger, and they will release the excessive pressure from the pipeline. So the second term is the cold difference test pressure. So it's inlet static pressure. So as I said just now, so once that we set the step pressure on 50, so when the cold differential test pressure is more than 50, then the valve will be triggered. So then the next one is the popping pressure. So is that the valve of increasing inlet static pressure at which the disc move and the opening direction at a faster rate, as compared with corresponding movement at a higher or lower pressure, which actually popping pressure is more like when we're doing the testing for safety valve, right, we always name it as a pop test. So the part I will explain later on in this slide why it's known as the pop test. So the popping pressure, you can put it in a way that is the pressure that the safety valve start to open. Then the fourth one is showing the slide is the overpressure. So overpressure means that okay, when the valve is open, how much of the overpressure it can cater. Then the next one is the blow down pressure. So the value of the discrete. So is that once that your valve is open, then definitely there is a flow being discharged, so your pressure it will slowly back to the normal condition. So that's actually means that the blow down pressure. And then I have a graph actually later on to show. I guess that will be much more clear for you guys. Yeah, so this is the graph that we show. So you can see that at point A, which is the second dot, which is the first dot from the right. So that is our, okay, maybe I can just say first. So for the y-axis is the lift of the disc, means at the opening of your safety valve. And then the x-axis is the pressure of your pipeline. So you see, okay, at the point of set A, right? So once that it reached to the, so when the pressure being increasing, when overpressure happen, so not overpressure means that when there's some equipment faulty at site, pressure builds up. So when it reached to the set pressure, so you can see the arrow is, so you can see the arrow, so the valve, safety valve, they start to open. So it will open at a stage that, okay, it's because it will start to allow the flow to flow through. So that's why the pressure will be increased, and then proportionally with the opening of your disc. And then when you reach to a stage of the maximum relieving pressure, so that is the maximum open of your safety valve. So once that it has been the excessive pressure has been relieved, right? So the pressure inside of your safety valve is getting lesser. So just because this safety valve is a reclosing, so it will slowly which we can call it as a close the valve back, or maybe you can call it as the reseating. So you can see from the graph is that the arrow actually going backward, and then and going downward means that your safety valve is slowly closing, and then up to the point where the pressure is lesser than the set pressure, then the safety valve is fully closed. Okay, yes, Jajarazin, pop test is same as hydro test. No, hydro test is more like testing the integrity of your valve body, or maybe your equipment on their capability to sustain the pressure up to the certain according to the ASME class, ASME pressure rating class. Pop test is more like we call as a functional test, just to test that whether your safety valve is set at is set at the right set pressure, and then it will it function when the pressure builds up until the set pressure. Okay, next one I'll talk about, yeah, this is our topic today, which is the pressure safety valve. So it can also be called as a spring-loaded safety valve, because you can see the mechanism actually quite similar compared to the pressure regulator that we had on last Thursday and this Monday. But you can see that, but on the overall look, on the overall physical appearance, there actually kind of difference. So in which you can see that for the safety valve, actually, they actually have, okay, which you can see in the purple section. So is the nozzle area is actually being controlled. So yeah, and then it's the same also being operated by the spring. Then and also the set pressure is also determined by the set screw. So which means that it still depends on how much of so it's like the trigger point is actually still determined by the spring force. So this is the seating chamber, and this is the close-up look at the seat area. So okay, the operation of the spring-loaded pressure relief valve is based on the force balance. Means that, okay, it's like the pressure at your flow line, at your pipeline. So once that it reach to a point that is over your set pressure, which is determined by your spring force, then the valve will be opened. Then yeah, this is okay. This show that when the pressure when the pressure is getting nearer to the set pressure, so your valve is actually your valve is actually being triggered. So as a result of the restriction flow between the disc holder and the adjustment ring, the pressure is built up in the hardening chambers, which you can see at the yellow section at the CFD diagram. So since pressure now acts on a larger area, so with additional force, so it's actually able to overcome the spring force and open up the valve. So once the valve has opened, actually there is an additional pressure builds up occurs, but this is due to the sudden flow of the increase at the restriction area. Means that the area is very small, but then there are the flow too. So with this accessing pressure, right, it actually act as an extra force in kicking your valve to open up even more. So that's where you can clearly listen the fluid being released, and then they have a pop sound. So this is where this is where the pop test being generally called off. So it's like so the next time when you are doing the testing for safety valve, definitely you will listen this pop test. And now you know that what this pop test actually means. Yeah, so this is showing, okay. So you can see from the CFD is that the pressure actually very high, and then it can be relieved to the downstream of your safety valve. So usually it will be in a closed loop, means that it will be released whether to a vessel or maybe to the pipeline. Then they will transmit it in some other storage area. So for the spring-loaded safety valve, actually there are two types. One is the spring-loaded, for spring-loaded safety valve, there are two types. One is conventional and the second one is balanced. So what is the difference between that? So for the conventional pressure, conventional safety valve, so it's actually is considered as a rather simple design. So it's designed to open as a, it's designed to open at a set pressure, and then okay, and then under the normal condition, right, so you can see that the disc and also the seat is intact. So which means that there is no flow, no flow, or maybe there's no any discharge from the pipeline. So the advantage of using the conventional safety valve is that this is rather reliable and also versatile because of the simplicity of the design. So it can be used in the different applications, and also but there is also a bit of disadvantage is that because due to the design, right, this not really considered as unbalanced, but then it will be affected by the back pressure. And is that back pressure means that the existing pressure at the downstream of your safety valve. So it's like this back pressure, it actually serves as another, we would say, as the resisting force when the safety valve had to open at that certain set pressure. So and if the back pressure is too high, right? So actually there are possible of having the, which we call as the chattering. Chattering means that the valve opening is not smooth, so it keep so the opening it keeps varies. So it's like open up, then close to the back, open up to the back, and then it happen in a very high frequency. Means that you will see your safety valve actually operating like this. Then this is the one we call as a balanced safety valve. So back to this slide, right, you can see that actually their design is more or less the same, but the difference is they are having this. Okay, you can see the diagram at the center, which we call as the bellow. So the the balanced safety valve, right? So the difference with the conventional is that they incorporate the bellows or others, or maybe some manufacturers they call it as others name. So it means to balancing the pressure between the flow line and also at the internal of your safety valve. So definitely when we talk about the advantage of the bellow of the balanced safety valve is that, okay, first of all, the back pressure doesn't affect much on your safety valve operations, so it can handle a very high build up back pressure, and also it can protect the spring from corrosion because your process flow actually is not contacting with your spring. But then there's still the disadvantage is that because once you have additional parts, means that you will, I mean, when you are doing the routine maintenance, so definitely there's one more part that you need to consider, and also you need to monitor during the maintenance. So okay, so yeah, as for the slide, a balanced pressure relief valve should be used when the blowout pressure is too high, and then the conventional type is much more simple. So it's that when there's no without any back pressure, then you still can opt to use by the conventional type. Right. So this is this is a schematic of the balance safety valve. So okay. So this part actually talk about the back pressure. So actually, okay, in simple term, there are actually two. So either whether they are the superimposed back pressure or the variable back pressure. So this thing I won't really touch really much first. Maybe I just have a brief through it. So if let's say the next time when we have much more advanced classes, and we will talk about what kind of the back pressure and what are the applications that we will need to take into consideration when we selecting our safety valve, because back pressure actually it will affect a lot more things during the sizing, because not only we need to consider on whether just balance type to be used, we also need to consider on the nozzle of the safety valve, means that the trim type of the safety valve to be used to cater for the applications. Okay. Right. So as you can see, right, so you guys might be wondering how come blood pressure can be affect too much. So for this one, so you guys can just take from the simplest schematic diagram as shown. So you can see that for the conventional types, so actually there are much more area for the blood pressure to act on the trim itself. So which definitely in order to, because as we mentioned just now, is that safety valve is actually considered as a balanced pressure device. So it's actually operate between so it's actually operate upon the differential pressure. So if you compare to the one that this one is for the bellow. So you can see, so you can compare these two, is that this is a conventional, this is a bellow. So you can see that the effect on the back pressure acting on the balance type, which having the bellows, is actually smaller compared to the conventional ones. Okay, so and we have another one which is the pilot operator safety valve. And yes, so basically for the pilot operator safety valve is the same, is their function are the same, just that they have another secondary relieving device, which is the smaller pilot valve, in order to operate the valve. So other than that, right, so the operating mechanism are still the same. So which you can, so this is the diagram of the so-called the pilot operating safety valve. So you can see that on the main valve, right, so it's still quite similar with the conventional type. Just that you can see that for the conventional types, right, you have the spring chamber is integrated in everyone all in one. But for pilot operator safety valve, you can see that you have the operated valve, the pilot operator valve, which having a small spring as the secondary valve. So these are the types, and this is mainly the calculation on the pilot operator safety valve. So actually the calculation is still the same, because it's still so the basic mechanism are still the same, except once that the pipeline pressure is achieved to the set pressure, then the safety valve it will trigger and open. Okay, so this is the external loops. And next one, I'll just talk about some of the internal parts of the safety valve. So this is the sealing. So for the sealing, so I remember that you guys still remember previously we have a session about O-rings, so which is done by Mr. Ng. Then if you guys is really interested in it, then you can actually play back the video are still so you can actually, for this 2-month session, you can always look back into our archive, or the so-called the video list, just whenever you want to have a revision. Okay, so I guess yeah, I'm a bit over time today, so I guess that's all for my session today. So before that, just maybe let me share a little videos on yeah. So just now I talked about the pressure, the pilot operator safety valve. Then maybe I'll just have a short video on how this valve actually operating, because some of you might quite blur on how the mechanism. So this is the cross section area. So you can see. Oh, maybe I just hide myself. Okay, so that's actually how the things works. Right, okay. Then maybe just have a quick one on the quiz today. So this is the question. Right. I'm not sure whether you guys are still with me or actually quite blurry. Right. So this is a quiz today. So can I ask, what is the type of the safety valve has been shown in the video just now? So for the price today, I'll have maybe I'll just have the same price. So which is the 20 ringgit of the Touch and Go cash voucher. So you can put in your answer in the comment. So we will attend to you. We will attend to you shortly. Yeah. So I guess that's all for my session today. Thanks for joining us. And yeah, I guess I'll see you guys again on no, I guess yeah, tomorrow we have another session. So that is on we have another session, and then we will continue our technical topic on next Monday. All right. Then till then, see you guys again. Thanks for joining us. I'm your speaker today, Calvin. Yeah, bye.